Welcome back students. So in this video we are going to see some more problems on probability. So those are next problem is in a sample of 446 cars stopped at a road block, only 67 of the drivers had their seat belts fastened. Then what he has asked is estimate the probability that a driver stopped at road will have his or her seat belts fastened. So this is the question he has given. So number of cars are 446 and the road block, they are stopped at a road block and 67 of the drivers have their fast turn. That means the favorable number of cases is 67 and total number of cases 446. So our required answer is 67 by 446. So simply for this type of problems we can see what is the huge value we take it as a less value we take it as numerator and the greatest value we take it as denominator. Simply we can see by that problem and we can simply write the solution for that problem. So next problem is what is the probability of getting phase 5 when die was rolled? So already we know that when a die was rolled it contains 1, 2, 3, 4, 5, 6. So the number of cases are 1 by 6. P of A equal to 1 by 6. So getting even cases, that means in 6 out of 6 we are having 3 even cases and we are having 3 odd cases. Suppose the even case, if you want to take the even cases, then we are having 3 even cases. So the number of favorable cases are 3 and total number of cases is 6. That is total probability is 3 by 60. 3, 6. 3 by 6, that is 1 by 2. Next, getting odd cases. So we are having 3 odd cases. So the total probability is 3 by 6, that equal to 1 by 2. So next we are going to see the addition theorem of probability of 2 events as well as 3 events. So now we are going to see the addition theorem of 2 events of probability. So it is the statement is if A and B are two arbitrary events or sample space of a sample space, then we have to prove that P of A union B equal to P of A plus P of B minus P of A intersection B. So for this, what we have to do is we have to take A and B are two mutually exclusive or arbitrary events of a sample space. Yes. So here one logic is A union B. So this can be written as a union of two mutually exclusive events, that is A and A complement intersection B. So this is the important logic we have to use in solving this theorem. So that is A union B. So this can be written as, so here we can see from the this Venn diagram. So A union B can be written as union of A and A complement intersection B. So this is the logic we are taking to solve this theorem. So P of A union B equal to P of A union A complement intersection B. So that means that is P of A union B. Next, P of A plus union means we already know that by third axiom union can be written as plus. So P of A plus P of A complement intersection B by the third axiom of probability. So now what we are going to take is we have to add and subtract P of A intersection B. So now I am adding and subtracting P of A intersection B. So there is no problem. Minus 1 plus 1 or minus 2 plus 2. So similarly plus A intersection B minus A intersection B I have taken. So now what I am going to take is P of A plus this 2 I am putting in one set. So that is probability of A complement intersection B and plus can be written as union A intersection B minus P of A intersection B. So this can be written as P of B. Why means you can see from this diagram also. So this diagram is called as Venn diagram. So this value become as P of B. Therefore P of A equal to P of B, P of A plus P of B minus P of A intersection. Therefore P of A union B equal to P of A plus P of B minus P of A intersection. Therefore the addition theorem of probability of two events is proved. This is simple logic. So in proving this theorem we have taken a simple logic, that is A union B can be written as union of A and A complement intersection. So this is the logic we have used in solving this theorem. Now we are going to see the addition theorem of three events. So I have taken the three events, that is A, B, C. So this can be written as P of A union B union C equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. So this is the addition theorem of three events. So P of A union B union C can be written as P of A union B union C. That means it is similar like A union B. So we already know that the theorem from second two events, that is P of A union B can be written as P of A plus P of B minus P of A intersection. So similarly we write like this by using the addition theorem of two events. We have to replace that. That means P of A union B plus P of C minus P of A intersection. Next P of A union B. This also can be written as P of A plus P of B minus P of A intersection B. So plus P of C minus this, by using the distributive law we have to distribute it. Then we have P of A union B union C equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. So this is a simple problem. Here we are going to use addition theorem of two events in 3 or 4 times. So that the theorem is very important in proving this theorem. So we have to use that theorem in proving this theorem. So this is the important logic we have to remember while doing this theorem. Next, here I have given the information about the cards. So total cards we are having 52. Out of 52 cards, we are having diamond cards are 13, spade cards are 13, 18 are 13, and Kalavar are 13. So As cards are 4, Queen cards are 4, Jockey is 4, King is 4. So total red cards are 26 and white cards are 3. So this is the information regarding the playing cards. So next he has given a theorem. Let P be an arbitrary function of a power set, then P of 5 equal to 0, next P of E complement equal to 1 minus P of E. So this we can simply prove by the formula E union phi equal to E and E intersection phi equal to phi. This is by the complement. So next we have to take the probability for this P of E equal to P of A union E union phi. So that is by the axiom, third axiom we can write P of E union can be written as plus P of phi. That means here P of E get cancelled, we get P of phi equal to 0. So it is proved. So next similarly we can take here E union phi E complement equal to S and E intersection E complement equal to phi. So I have to take the probability. So I have taken the probability here. So union by third axiom we can write union in place of plus. So I have written the plus here. Next we already know that by axiom of 2, that means axiom of certainty says that probability of entire sample space is equal to 1. So that means P of S equal to 1. Therefore P of E complement equal to 1 minus P of E. So my theorem is proved. So this is the simple theorem we can easily prove. So the next definition is power set. Power set means P of A. So the set of all subsets of a given set A is called as power set of A and it is denoted by P of A or simply by rho of A. If A is a set within the n elements, then it is called as power set. It is denoted by P of A. That means it contains 2 power n. So this is the important definition for 2 marks he will give for 2 marks. So next he has given a problem next. P of A, he has given P of A equal to 1 by 5, P of B equal to 2 by 3 and P of A intersection B equal to 1 by 50. Then he is asked to prove this 5. That means P of A union B, P of A complement intersection B, P of A intersection B complement, P of A complement intersection B complement and P of A complement union B complement. So now we are going to prove that. So we already he has given P of A equal to 1 by 5, P of B equal to 2 by 3 and P of A intersection B equal to 1 by 50. So we already know that the addition theorem of two events P of A union B can be written as P of A plus P of B minus P of A intersection B. So on substituting these values we get 4 by 5. So the next one is P of A complement intersection B. So that equal to P of B minus P of A intersection B. So that means if we subtract from that we get 3 by 5. Next this is by De Morgan's law. So here this comes from the De Morgan's law. So next P of A intersection B complement. That means P of A minus P of A intersection B. So we already know that P of A is 1 by 5 and P of A intersection B is 1 by 50. So on minus on subtracting we get 2 by 50. Next P of A complement intersection B complement. That means this can be written as P of A union B whole complement by De Morgan's law. So this can be written as 1 minus P of A union B. That means 1 minus, already we know that the P of A union B is 4 by 5. So 1 minus 4 by 5 we get 1 by 5. Next P of A complement union B complement. This can be written as P of A intersection B whole complement. That means 1 minus P of A intersection B. So we already know the P of A intersection B value is 1 by 50. So 1 minus 1 by 15 that equal to 4 by 50. So these are the solutions for the given problem. So similarly we can do this problem also like this. So these are some of the problems on